Hello, this is video lesson number 15 on limiting reagents in stoichiometry. I am making a video for this lesson because you will need to stop the video, work the math problems, and come back and check your own understanding. This will take time, perhaps a half hour to an hour to go through this video, but I want you to work at your own pace because your practicing ensures your understanding. I'm going to be sharing my screen from your class packet, pages 12 to 15. To do this video, you're going to need a calculator and a periodic table. On page 12 in your class packet, we have our introduction to limiting reagents. Sometimes they're called limiting reactants. Consider the reaction of hydrogen gas with oxygen gas to form water. Let's assume it's liquid water for this example. I would like you to write the balanced chemical equation on that line. All stoichiometry starts with a balanced chemical equation. Now, I'm sure you've gotten this balanced chemical equation correct, 2 to 1 to 2 being the coefficient ratio between reactants and products. I know you don't usually write the 1, but I'm emphasizing it here for you. Now, what do those coefficients mean? I'd like to remind you that there are 3 meanings of coefficients. The coefficients in a balanced chemical equation can represent the volume of a gas, the moles, or the number of particles. Coefficients do not represent the mass of any chemical in a balanced chemical equation. These are the 3 meanings of the coefficient, but emphatically not the mass. So for this situation, I'd like to consider the coefficients as being particles. Now, this is a reaction chamber, and I'm not trying to represent the balanced chemical equation. Instead, I'm giving you an amount of reactants. I am giving you 2 oxygen molecules and 7 hydrogen molecules. I would like you to see that these molecules in the reaction before it occurs, the reaction chamber, react in a 2 to 1 ratio. So for every 2 hydrogen that I cross off, I need to cross off 1 oxygen and make 2 water. Cross off 2 more hydrogen molecules and 1 oxygen molecule and make 2 waters. Now, if their waters are in the liquid state, they're going to be puddled down in the bottom of this reaction chamber visual, which is a box. Will there be anything else in this reaction chamber after you've made all the water possible? Yes, you'll see that making 4 water molecules does use up all of the oxygen, but you still have these 3 hydrogen molecules left over. And so the limiting reagent is the oxygen. We ran out of oxygen while making water. The chemical in excess is hydrogen. And then you think through these 3 questions here at the bottom. So, which is the limiting reactant when 10 grams of hydrogen is mixed with 50 grams of oxygen and the reaction and the mixture is ignited by a spark? So now I'm giving you masses. You can tell this is a limiting reactant problem by this important clue. I have given you 2 quantities of reagents. Whenever you see 2 quantities of reagents, you know it's a limiting reagent problem. How much water are you going to make? Will it be the amount of hydrogen that limits the amount of water that's made? Or will it be the amount of oxygen provided in this problem that limits the amount of water that's made? So how do you do this? You actually do 2 stoichiometry problems. You take 10 grams of hydrogen through the stoichiometry and tell me how many grams of water are made. Then you take 50 grams of oxygen through the stoichiometry and tell me how many grams of water are made. I'd like you to diagram this balanced chemical equation first. Oops, sorry. So here's the diagram, and I want you to pause the video and do the two stoichiometry problems. Write the two-dimensional analyses on the bottom of page 12. Stop and come back. This is what you should have for your stoichiometry. Taking the 10 grams of hydrogen through to the quantity of water, you possibly could make 89.2 grams. Taking the amount of oxygen provided in this problem through to the water product, you would make 56.3 grams. Now, which possibility of water production is going to be the reality? It will be the smaller amount of water that's actually made. So I highlight this 56.3 grams, emphasizing that that reactant then must be the limiting reactant. All right, let's turn to page 13 in your class notes and we'll work through problem number 2. Remember, the reason we're doing this on a video is so that you can stop the video, work the math, and build your own understanding. Watching me do it will not ultimately help you solve these problems yourself. I want you to pause and do the math. All right, page 13. Consider the burning of methane in the presence of oxygen gas. Pause right now and write that balanced chemical equation. All right, I am hoping that you have the coefficient of 1 in front of the methane and the coefficient of 2 in front of the oxygen. If you have a correct balanced chemical equation, we can go on and consider A. Glancing down the whole page, you'll see that I'm going to be considering coefficients in A as if coefficients can be molecules. When I go to 2B in the middle of page 13, we'll be considering coefficients as representing moles. And when we go to 2C, I'm asking you about mass. I'll emphasize at that point that coefficients do not represent mass ratios. So from your balanced chemical equation up at 2A, I'd like you to consider being given 50 molecules of methane and 50 molecules of oxygen. Write those two numbers underneath the methane and the oxygen and go ahead and answer these questions. You need to be able to recognize, comparing the coefficients to these numbers of molecules, which reactant is excess and which is limiting. How many molecules of product can be made? All this is done by comparing only the coefficients. Pause and answer these questions. So, from looking at the 50 and 50 molecules compared to the 1 and the 2 coefficient, you can see that it must be oxygen that's the limiting reactant, because if you are able to react 50 molecules, you only need half as much methane. That would be 25 molecules. Do you have 25 molecules of methane? Yes. So methane cannot be the limiting factor. Let's go the other way. If you have 50 molecules of methane and you're going to use them all, you would need 100 molecules of oxygen. Are you given it? No. So you must run out of the oxygen. making oxygen the limiting reagent, and necessarily using oxygen to do the math considerations as to how much product is formed. B, if you write the equation over again, right underneath B in the middle of page 13, you'll see that in this problem we have the same equation, but now we're talking about being given 3 moles of methane and 10 moles of oxygen. New math, new considerations, but remember, coefficients can represent mole ratios. So you don't have to do a lot of stoichiometry here. You can compare the 3 and 10 right with the 1 and 2 as the coefficients. Do this math and answer these questions down here. Pause before you go on. So in this problem, the limiting reagent is the methane. Will there be any left over of the limiting reagent? No. You always have to do the math as to how much product can be made by using the limiting reagent. Now C on the bottom, if you write the equation over again, you'll see that it's the same balanced chemical equation, but now you're being given 50 grams of methane and 50 grams of oxygen. Write the balanced chemical equation and put these two numbers underneath methane and oxygen. Now you're going to have math to do. Coefficients do not represent, well, you always had math to do, but now you're going to have to do extensive stoichiometry. You'll have to figure out how much water would you make if 50 grams of methane was used all the way to make water? How much water would you make if 50 grams of oxygen was used all the way to make water? You're going to do 2 stoichiometry problems because this is your classic limiting reagent problem. You're given 2 masses, mass of 2 reagents. And so you need to do a limiting reagent calculation. Pause and do 2 stoichiometries, taking both of these masses through to a mass of water being made. Stop and do it. All right, so this is what you should have on your paper. Taking the 50 grams of methane through stoichiometry, you get 112 grams of water. Taking the 50 grams of oxygen through the stoichiometry, you only get 28.2 grams of water. You have to do 2 problems to solve a limiting reagent problem. But now I recognize the smaller quantity of product will be the actual result. And so oxygen is the limiting reactant. And that's the answer I write for how much water will be produced. Now, I on the very bottom is a new type of problem. And I'd like you to consider this uniquely. How would you determine how many grams of excess reagent are left over? This is like a backwards stoichiometry. Since you now know oxygen is the limiting reagent, you would need to do a stoichiometry of 50 grams of oxygen requires how much methane being consumed. Do the stoichiometry to figure out how much methane would be consumed in reacting all of 50 grams of oxygen. Pause and do that calculation. And so the limiting reagent of 50 grams of oxygen would require 12.5 grams of methane to be consumed. You have it. You have 50 grams. And so if 12.5 grams would be consumed by using all of the limiting reagent, you can see that that subtraction problem provides the amount of leftover methane when the reaction has gone to completion. So you have now done page 13, and I'd like to consider the next page. All right, page 14 in your class notes, we're going to continue with the next limiting reagent problem. Now this one you're going to do from beginning to end, and it's a real test of have you understood the last couple of examples. Number 3 on page 14, sodium reacts with chlorine rather violently, you betcha. If 71 grams of sodium are placed in a container with 200 grams of chlorine, how many grams of sodium chloride are produced? Notice you can tell this is a limiting reagent problem because you were given both a mass of sodium and a mass of chlorine. Right there, you know you have more math to do to solve this problem. Now, if you would pause, please, and write the balanced chemical equation. We've got to make sure that's correct before you spend the next 5 minutes doing math. So write the balanced chemical equation and come back in 20 seconds. All right, do you have 2 sodium plus 1 chlorine gives 2 sodium chloride? It's the sodium chloride that's the salt that they're referring to. From that balanced chemical equation, and you can put the phase notations in, you now are asked, what's the limiting reagent? This little blank right here requires 2 very long stoichiometry problems. So please do the work now to calculate how much salt are you going to make if you start with 71 grams of sodium, and then do a second stoichiometry, how much salt or product, sodium chloride, will you make with 200 grams of chlorine? So right here is the space to do those 2-dimensional analyses. You can ultimately tell me how much product is formed. Oops. And then, I'm sorry. And then for E on the bottom of page 14, that question, how many grams of excess reagent are left over, requires you to do the kind of problem that was on the very bottom of the previous page, page 13. To do E, you have to work backwards from the limiting reagent to figure out how much of your other reagent you need to use all the limiting reagent. Pause now and do about 10 minutes worth of math. So here's what your math should look like. Doing the 2-dimensional analyses to calculate the amount of product you would get from the 2 quantities of reagents provided, you would make the smaller quantity of product. And so sodium is the limiting reagent that allows you to answer the rest of the questions and then do this backwards. That's my term, nobody else's term. Stoichiometry to figure out how much chlorine is used up by using all of the limiting reagent of the sodium. Then you subtract to find out how much chlorine is left over. All right, next page. Page 15 is our last big problem for you to show me you can do this all yourself. Please pause and first carefully read this opportunity to write a balanced chemical equation from my description. This is a testing skill. Pause and write the balanced equation. You should have a balanced chemical equation that talks about 2 ammonia molecules, 3 copper Roman numeral 2 oxide particles, produces 1 nitrogen molecule, 3 copper atoms, and 3 water molecules. Have you got that for your balanced chemical equation? Because if you don't have that, stop. Go back and figure out the balanced chemical equation. Because now you're going to invest about 10 minutes doing 2 stoichiometry problems, taking 18 grams of ammonia through to how much nitrogen gas is made, and then take 90.4 grams of cupric oxide through the stoichiometry and calculate how much nitrogen gas could be made from that amount of reactant. From that, you can tell me what's the limiting reagent, how much nitrogen do you really make, and how much excess reactant is left over. Come back when you got the math done and check your answers. Here you have all the work that should be on the page now that you've done it. This is quite the accomplishment. I commend you having done 4 limiting reagent problems in this class packet. This should prepare you for the end of stoichiometry. It doesn't get any harder than this. This is it. Limiting reagents, and we are done with the class packet on limiting reagents. Thank you very much for this time. Bye.